In this video, we will be talking about three different topics. Number one, percentage composition. Number two, empirical formula. And number three, molecular formula. So we'll discuss all these three topics one by one. So let us first see what is percentage composition. So it is the ratio of the amount of each element to the total amount of individual elements present in the compound multiplied by 100. Here we measure the quantity in terms of grams of the elements present in the solution. So theoretically, the percentage composition of any element is an expression of its composition in terms of all the elements present. Next, we will be learning the formula for percentage composition. So the percentage composition of a given element is given by the following formula. Percentage subscript CE is equals to G superscript E divided by G superscript T into 100%. Here, percentage CE is the percentage composition of the element E, G superscript E is the total amount of element E present in the compound, and G superscript T is the total amount of all the elements present in the compound. Next, we will be learning about mass percentage composition. This concept is used to denote the concentration of an element in a compound or a component in a mixture. Mass percentage of an element is equal to mass of the element in the compound divided by molar mass of the compound into 100. Now, we will be learning about determination of mass percentage from a chemical formula. So let us understand it by taking the example of water, that is H2O. First of all, we will calculate the molar mass of each of the element as well as that of the compound. So, molar mass of oxygen is equal to 16.0 into 1, since only one oxygen atom is present in the compound, which is equal to 16 gram per mole. Next, molar mass of hydrogen is equal to 1.01 into 2, since there are two hydrogen atoms in the compound, that is equal to 2.02 gram per mole. And molar mass of H2O molecule, that is the compound, is equal to the sum of the molar mass of oxygen as well as of the hydrogen atom, that is equal to 18.02 gram per mole. Now we will find the percentage composition of each of the element in H2O. So percentage of hydrogen atom is equal to the molar mass of the hydrogen atom divided by the molar mass of water, that will be equal to 11.21%. Similarly, percentage of oxygen will be equal to 16.0 divided by 18.02 into 100, which is equal to 88.79%. So now importance of mass percentage. If the mass percentage of various elements present in the compound is known, empirical formula can be determined. Similarly, molecular formula can further be obtained if the molar mass is known. So the problem states that a compound contains 4.07% hydrogen, 24.27% carbon, 71.65% chlorine. Given the molar mass is 98.96 gram, what are the empirical and molar form? Next, since we are having mass percentage, so it will be convenient to use 100 gram of the compound as the starting battery. Thus, we write that 100 gram as the starting battery. That is, the mass of hydrogen, carbon and chlorine all together will be equal to 100 gram. Next, we write 4.07 gram of hydrogen, 24.27 gram of carbon and 71.65 gram of chlorine. So in short, we can say in place of the percentage symbol, we are putting the gram symbol. Next, we need to find the number of moles of each element. So number of moles of hydrogen is equal to the given mass divided by the molecular mass, that is 4.07 divided by 1.008, which is equal to 4.0. Next, number of moles of carbon, which is equal to given mass divided by molecular mass, that is 24.27 divided by 12.01, which is equal to 2.021. And at last, number of moles of chlorine, which is equal to given mass divided by molecular mass, that is 71.65 divided by 35.45, which is equal to 2.02. Next, we need to divide the mole value obtained above by the smallest value. So out of the three mole values, we find that 2.021 is the smallest value. Since 2.021 is the smallest value, we divide all the number of moles value by it and get a ratio as 2:1:1 for H:C::C. In case the ratio are not whole number, we will try to convert it into whole number by multiplying with suitable coefficient. So thus we can write the empirical formula as C. Since the ratio of carbon is 1, so C 1. For hydrogen it is 2, so it is H2, and for chlorine it is 1, so it is C. Thus the empirical formula is CH2C. Next, we need to find the molecular formula of the compound. So to find out the molecular formula, first of all, we need to determine the molecular formula mass. To determine it, we need to add the atomic masses of the various elements present in the empirical formula. Thus, for CH2Cl, the empirical formula mass is equal to the mass of the carbon, that is 12.01, plus twice into the mass of hydrogen, that is 2 into 1.008, plus the mass of chlorine. So we get it as 49.48 gram. Next, we need to divide the molar mass by the empirical formula mass. Here, the molar mass is 98.96 divided by 49.48. So we get it is equal to 2, which is equal to N. So to obtain the molecular formula, we need to multiply the empirical formula with N. So empirical formula into N is equal to molecular formula. So for the empirical formula CH2Cl and for N value 2, we get the molecular formula as C2H4 and Cl2. Thus, this is the molecular formula of the compound.